Welcome to the Industrial Stormwater Certified Operator Training. The slide on the screen lists the topics we will discuss during today's training. Your questions and input related to the Industrial Stormwater Program are encouraged. The questions you ask may help others and will make this training program more useful. This is Stormwater, and this training is specifically designed to increase your understanding of the role of a certified stormwater operator. It is designed to work with the Industrial Site Stormwater Certified Operator Training Manual and to enhance your understanding of the requirements of the Industrial Stormwater Program. In addition, this training will provide you with guidance to assist you in your duties as a certified operator. Let's begin with a brief overview of the water quality issues, especially where they relate to precipitation and runoff. From a raging stream during spring snowmelt to a gentle summer rain, to the slow movement of water through the ground, water is in constant motion. The movement and endless recycling of water between the atmosphere, the land surface, and underground aquifers is called the hydrologic cycle. This movement, driven by the energy of the sun and the force of gravity, supplies the water needed to support life. Understanding the hydrologic cycle is basic to understanding all water and is a key to the proper management of water resources. Many processes work together to keep the Earth's water moving in a cycle. There are 5 processes at work in the hydrologic cycle: condensation, precipitation, infiltration, runoff, and evapotranspiration. These occur simultaneously and, except for precipitation, continuously. Stormwater and runoff are part of this natural hydrologic process. Under natural conditions, the majority of rainwater that falls to the ground infiltrates the ground or evaporates. However, industrial activities can alter the natural drainage patterns and add pollutants to rainwater and snowmelt. The introduction of pollutants to stormwater most commonly occurs when industrial facilities allow operating procedures and industrial materials to become exposed to stormwater. This potentially contaminated stormwater may then enter our lakes, rivers, streams, and wetlands. The best way to combat this is through pollution prevention. It is better for the environment and more cost-effective to prevent the contamination of stormwater at the source. This concept has led to the development of the current stormwater regulations. The goal of the stormwater program is to reduce the pollution entering Michigan's waters by implementing controls designed to prevent the contamination of stormwater runoff. Most automobile drivers are aware that roads are slickest after the first few minutes of a rainstorm. It is in those first few minutes that oil, grease, and other pollutants that have accumulated on the pavement are picked up by water and transported to the storm sewers or roadside ditches. This washing action by the stormwater is referred to as the first flush. It has been determined that this first flush of stormwater runoff contains the highest percentage of pollutants. There are a variety of pollutants commonly found in stormwater that can impair water quality. Common sources of hydrocarbons, gas, oil, and grease, and industrial stormwater runoff are from spills at oil storage and fueling facilities, automobiles and equipment, and improper disposal of waste oils. Hydrocarbons are known to be toxic to aquatic organisms at a relatively low concentration and are a major concern when addressing stormwater runoff controls. Sources of toxic pollutants are quite varied. Pesticides, herbicides, metals, wood preservatives, oil-based paints, used oils, and solvents all have toxic effects on aquatic life and may contaminate drinking water supplies. Some toxic substances can accumulate in the food chain, resulting in fish advisories, limiting the amounts and types of fish we can safely eat. The following activities can lead to organic enrichment: food processing, compost operations, failing septic systems, animal waste, airplane de-icing activities that use glycol-based products, and improper handling of antifreeze. Stormwater runoff can deposit large quantities of these substances in our lakes or streams. As these substances are being broken down by bacteria, levels of dissolved oxygen in the aquatic environment are decreased. Oxygen depletion is a common cause of fish kills and odor problems, especially in areas of shallow or slow-moving waters. Nutrients are typical pollutant associated with stormwater runoff. The addition of phosphorus to stormwater runoff from landfills, sediments, septic fields, sewage, animal waste, illicit connections, and over-fertilization result in algal blooms and excessive plant growth. The presence of pathogens in surface water inhibits recreational uses such as swimming and boating and can cause ear and intestinal problems as a result of contact. Common sources of bacteria are illicit connections, sanitary sewer overflows, animal waste, and failing septic systems. Sediment is one of the most widespread pollutants in surface water. Sediment that is suspended in the water causes it to appear cloudy or turbid. It is generated from construction activities, bare soil around a facility, gravel parking areas, and stream bank and stream bed erosion. Many pollutants such as nutrients, hydrocarbons, metals, and other toxic substances attach to sediment particles, particularly fine sediments such as clay. Therefore, as sediment is carried to a water body, it can carry other pollutants with it. Even without attached pollutants, sediment can be very destructive to aquatic systems by covering and damaging habitat. The most common source of chlorides and other salts in urban stormwater runoff is de-icing of impervious surfaces such as roads, parking lots, and walkways. Because salt is extremely soluble, almost all salt applied to roads, parking lots, and walkways ends up in surface or groundwater. High chloride concentrations can be toxic to many freshwater organisms, and there are numerous documented cases of water contamination caused by stormwater runoff from inadequately protected stockpiles of salt and sand-salt mixtures.